Hello, and welcome to the last video in this series on plotting with ggplot data that is originally stored in a CSV file. This specific video series is for compression data from Instron testing. So in the first video, we showed how my data could be read into a data frame, and that data frame could be formatted to remove the value on row 1 that shows units and isn't actually numerical data. Once we've done that, we want to load the tool that we're going to use for graphing. So we load that with library tidyverse. And then we want to get into the calculations we need to go from raw mechanical testing Instron data to actual elastic modulus values. And the first thing we need for that is to define the size of the sample tested. So these were 3D printed cylinders that were compressed. You know that the cylinders were 10 millimeters wide. So their cross-sectional area would be pi times 5 squared. And they were 20 millimeters tall. Once we have those values defined over here in our environment, these are things that we can use to modify our data stored in my data too. So the first thing I'm going to do is I'm going to make a vector of the calculated strain. So strain is going to be extension divided by height. Next, I'll make a vector of the calculated stress. That will be load divided by cross-sectional area. Once I have these two numerical vectors, I want to put them together into a new data frame. You saw how in lines 11 and 14 I used the as.numeric function. That's something that's necessary in R and not necessary in other programming languages. One of the things that you will notice is that we don't have a section at the top of our script to define variables and what type of data they are. Instead, we use as.numeric, as.dataframe, as.character to define, when we make a new variable, what kind of variable we want it to be. Now we can bind the two numerical vectors together into a data frame using the cbind function. And we have our data stored in a data frame, so we can use ggplot to see what it looks like. The way ggplot works is it has an initialization command that's stored in a variable called p, and this plot information that's stored here needs to know the name of the data frame and what column in the data frame is X and what column in the data frame is Y. Then we can run what type of plot we want. In this case, we want a gm_point plot or a dot plot. And when we run the function, we actually don't see the plot. It's not until we run the line with just the name of the plot data that we see the plot pop up in our preview window. So you can see that this data includes a lot of preloading and a lot of deformation. It's only the area here that we're interested in, because this linear region is what's going to give us an elastic modulus value. This is the only part of the experiment where the material is acting in an elastic manner. So we can define this linear region through trial and error. I went back and forth and figured out that the value from 460 to 500 was the most linear. And the other thing I wanted to do was set this initial stress and strain to 0. So I have a new numerical vector that I'm creating out of my old numerical vectors that's much shorter and starts at 0. And then I'm going to do the exact same thing I did on line 17. I'm going to use as.data.frame with cbind to create a new data frame with the new stress and strain values. Now when I make a plot, I'll see a linear region, and I won't see the part of the experiment for preloading or the part of the experiment where the sample was being deformed. Now that I have only the linear region shown, I can add an additional statement to my ggplot. So you see this plus symbol here? Anytime we want to add formatting to our graph, we add a plus and we add an additional statement. This will enable us to change the color of the dots to blue and add a smooth linear model, LM stands for linear model function, onto the graph. So I run these two lines and I have a new plot that has a best fit line. But I don't want that to be the final version of the plot. I want to actually know what is the slope of the best fit line. That is actually going to be my elastic modulus. I also want to know how good of a fit is it to this region of data. So I want to display the R squared value. To do that, I'm going to call the lm function. It's the same thing that I ran within ggplot, but I'm going to call it separately to find out what the value is, and then use the values in this list with the format function to get an actual number. So I can get a value for my modulus, a value for r squared, all coming out of that m object that was created when I ran the linear model function. And I can turn those numerical values into strings with the paste function to create two different labels that I can put on my graph. One that will tell me the elastic modulus, and one that will tell me the r squared value. So now I'm ready to make the final plot for the lab report. The couple of things that I want to change from our previous plot. So I want to make sure that the stress and the strain have units, and I want to add with gm_text 2 new labels, my label 1 and my label 2, to display the elastic modulus and the r squared value. And now I have a final graph to put in my report.